Hello everybody. Here we have a question which looks like a geometry question, but it's actually a calculus question. Okay. All right. Let's get started. Uh, what we are given is a triangle PQR with angle Q being 45 degrees and a rectangle KMOT inside the given triangle as shown. Okay. We do not know the dimensions of the rectangle KMOT. Alright, okay. But it is given that QR, this length is 20, and PS, this length, it's 8. Okay. And even though we do not have the dimensions of the rectangle, it is given to us that, KMOT. Okay. That the area of rectangle KMOT is maximized. Okay, it's maximized. And furthermore, we are given that OF, this length, is equal to 3/4 of the entire length OM. Okay, so if this length is say Y, then this length is 3/4 Y. Okay. And OU is a parabolic arc with focus at F. So we are given a part of a parabola. Okay, we are given a part of a parabola whose focus is at F. And yeah, that's all we are given. Okay. And we need to find the area of the shaded region, this region, okay, bounded by this line, and the parabolic arc. All right. Then let's get started. 20 and 8. Let me just write that down. This is 20 and this is 8. Okay. This is 8. Now let us suppose that the length KM is equal to X. Then since this is a rectangle, OT will also be equal to X. And if we suppose this is Y, then this will also be Y. Okay. So as a result, area of the rectangle is XY. But we do not know the values of X and Y just yet. We need to use this condition. Okay, the maximized area condition. Okay, this is 45, 28. Okay, now let me erase this. Now let's look at the bigger triangle. Okay, let's look at the bigger triangle. Triangle PKM. Since these two lines are parallel, KM is parallel to QR, triangle PKM is similar to triangle PQR. Okay, because this angle is equal to 45 degrees, being corresponding angles. And if this angle is, let's say, alpha, if this angle is alpha, then this angle will also be alpha. Since this angle is equal to this angle and this angle is equal to this angle, we have two pairs of equal angles among the two triangles. So these two triangles, this triangle and this triangle, they are similar. Okay, so we've shown that triangle PKM is similar to triangle PQR, and now using the proportionality condition for similar triangles, we're going to get, let's see, we'll get, alright, this will be perpendicular. Okay, this will be perpendicular. We'll and since this is 8 and this is y, this length PV, this will be 8 minus y. Okay, we'll use that in just a moment. Okay, now let's see, x over this, x over 20 will be equal to, corresponding sides are proportional, isn't it? So corresponding to alpha, we have this side for smaller triangle and this side for the bigger triangle. So PK over PQ. Now let's see, 90, 90, 45, 45 means triangle PKV is similar to triangle PQS. And let's see, PK by PQ, hypotenuse by hypotenuse, is equal to this side over this entire side. So it's 8 minus y over 8, isn't it? Yes. So ignoring this part, we're going to get 4 2s are 8 and 4 5s are 20. So 2x by 5 is equal to 8 minus y, which means y is equal to 8 minus 2x by 5. So if A is the area of the rectangle, then A is equal to x times y. Now using this value of y, we'll get x times 8 minus twice x by 5, okay, twice x by 5, which is equal to 8x minus twice x squared over 5. Now since we don't know the value of x, there can be many rectangles, okay? A rectangle can be like this or like this. So x is not fixed as of yet. X is not fixed. So the area A of this rectangle, okay, there can be many other rectangles. So the area of a rectangle within this triangle, like this, is a function of x. So we can say that A is a function of x. That's why we can use this notation. Now, what were we given? We were given that the area of this rectangle is maximized. So this is a very nice function. So for maximum or minimum, we need to differentiate this function, okay? We need to differentiate this function. 8 minus 2 times twice x is 4x over 5, okay? Now let's look at the second derivative. It will be minus 4 over 5, which is not equal to 0. So this is what we need for the value of x, giving us the maximum value of the area of the rectangle, like this. This is not the only rectangle. Let me repeat. There can be another rectangle like this or like this. So x is not fixed, okay? So, but when it is maximized, there must be some value of x which maximizes the area function A, okay? So A is maximized means we need to set this thing to 0, which will give us which will give us 4x over 5 is equal to 8. This is equal to 2. So x is equal to 2 times 5, which is equal to 10. So if x is equal to 10, okay, so if x is equal to 10, then the area is maximized, isn't it? So the required value of x for the given condition, under the given condition of maximality, is x equal to 10. Now, if x is equal to 10, then y is equal to 8 minus 2 times 10 over, using the value of x in this equation, okay, we get 8 minus 2 times 5 over 5. This is what I've done here. This is equal to 4. Okay, so we have x equal to 10. Okay, x equal to 10 and y equal to 4. Y equal to 4. Okay, all right. Now, let's see. This angle is 45 degrees, so it may not look, but this side will be equal to this side, isn't it? 4. And this side is 10. So this length QO is 14. And so 20 minus 14 is 6. Hence we have OR is equal to 6. Okay? OR is equal to 6. Next. Next. OR is equal to 6. Now, what were we given? I forgot. OF. Yeah. OF was given to be 3 by 4 times OM. Since OM is equal to 4, this will be 3 and this will be 1. Okay, FM will be 1. Now, in order to find the area of the shaded region, we will find the area of triangle ORM and then subtract this red area. Okay, and subtract this red area to obtain this black area. All right. Okay. Now this curve is a parabola, so we must use integration. So we're basically done with the triangle part. Okay, this part. We need to focus on this part right here. So right off the bat, we have ORM, triangle ORM is equal to half times 6 times, since this is right angle triangle, half times 6 times 4, which is equal to 6 times 4, which is equal to 3 times 4 means 12. Okay, so triangle ORM is 12. We write it like this, 12. Now to find the area of the red region, we use a coordinate system, okay, with origin at O, positive x direction over here and positive y direction over here. So let's see. Positive x direction, positive y direction. Here's O. O is taken to be the origin. This is 90 obviously. and here's M, here's R, and here's the parabolic arc OU. Okay? Now, the coordinates of R are, since this length is 6, this is 6, 0, and since this length is 4, this is 0, 4. Okay? Now, to find the area of this red region, we can find the area of this part, okay, this part and this part. Let's say the area of this part is A1 and this part is A2. Okay. Now for this, if we can find the length U dash and U dash R, we're done because it's a right angle triangle. Now for this part we need to use integral calculus. We need to integrate something. Okay. What was F? F. The coordinates of F are, since this length is 3, the coordinates of F are 0, 3. Okay. Alright. Now we do not need this. Let's see. Recall that parabola. We have a parabola. Okay. We have a parabola. Focus at F means 0, 3. 0, 3. Or let's say 0, A, and vertex at origin. Vertex at 0, 0. Okay. Focus at here, vertex at here. Then, in this case, the equation of the parabola will be y is equal to x squared over 4a. Okay. Usually it is written as x squared equal to 4ay, and a is not equal to 0, so the division is allowed. So this is the equation of this parabola, isn't it? Okay. This is y is equal to x squared by 4, but instead of a we have 3, so this is 4 times 3, which is 12. So the equation of the parabola is y is equal to x squared minus 12. Now we need the coordinates of this point U. Okay, U. So U is the intersection of this parabola, and this parabola, and the line given by, since the x-intercept is 6, x over 6 plus y-intercept is 4, so y by 4 equal to 1, which is, I guess, 4x plus 6y is equal to 24, which is nothing but twice x plus 3y minus 12 is equal to 0. Now we need the intersection of this line and this parabola. Okay, so using y equal to x squared by 12 in this equation, we get twice x as it is plus 3 times x squared over 12. Okay, x squared over 12 here minus 12 is equal to 0. Okay, so this will be equal to 3x squared plus 12 into 2 means 24x. Okay, 24x minus, did I make any kind of mistake? I don't think so. Okay, 24x minus 12 times 12 means 144 is equal to 0. Okay, now we can divide this equation by 3. Let me just check. 4, 6 times 4, 24. 2 is common, so 2, 3, 12 minus, yeah. So it is x squared plus 8 times x minus, I think it's 48, or not. 48 times 3 means 24, 2, 3 times 4 means 12, plus 2 means 144, yeah. So 48 is equal to 0. Okay, now we can factor this out as x squared plus 12x minus 4x minus 48 is equal to 0. So x plus 12 minus 4, x plus 12 is equal to 0. This is, how much is this? X minus x plus 12, it's common. And x minus 4 is equal to 0. So we can have either x equals to minus 12 or x equal to 4. Or x equal to 4. Now, which value should we choose? Let's see. X equal to minus 12 means somewhere over here, isn't it? Somewhere over here, and the coordinate, if y is positive, then we have a point over here. If y is negative, then the point will be here. And but this is not the given case. Okay, this is not the given case because the x coordinate of u is positive. See, it's positive. So we do not take this value. Hence, the x coordinate of u is 4. And for the y coordinate, we substitute x equal to 4 in this equation. We'll get y equals to 16. Yes, 16, because 4 squared. Okay, 4 squared over 12 means 16 by 12, which is equal to 4 over 3. 4 times 4 means 16. 4 times 3 means 12. Okay, that's y. So the y coordinate of this point is 4 by 3. Okay. All right. Okay, we first calculate A1. Okay, A1 is equal to, it's the curve, the area bounded by the curve y equal to x squared by 12, x equal to 0, x equal to 4, and the x-axis. So 0 to 4, y means this, so x squared by 12 dx. This is equal to 1 by 12 into x cubed by 3 evaluated over from 0 to 4 means 1 by 12 into 3. 4 cubed minus 0 cubed. So it's basically, how much is this? This is 64 by 12 into 3. 4, no. 4 times 16 and 4 times 3. Yeah. So this is 16 over 9. Okay, A1 is 16 over 9. Now A2, let's see. Since this is 4, 4 by 3, this is 4, okay. Let me clear this out. This is A1, this is A2, okay. Since this is 4 by 4, 3, this length is 4 and this length is 4 by 3. So this length, this entire length is 6, means this length is 2. Okay, this length is 2. So the area A2 is the area of this right angle triangle, which is equal to half times 2 times 4 over 3. 4 over 3. So 2 and 2, they get cancelled out. This is basically 4 by 3. And just to make the addition simpler, I'm going to write it as 12 by 9. Okay, 12 by 9. So red area is equal to A1 plus A2, isn't it? So let's say red area is equal to, let's say R is equal to A1 plus A2, which is equal to 16 plus 12 over 9, which is equal to 28 over 9. Is it? 8 and 2. Yeah. 28 over 9. Hence, required area is equal to triangle O. This was R, I guess. Triangle ORM, the entire triangle, minus R, okay, minus R, and triangle ORM was 6 times 4 into half, means 12. Yeah, 12 minus the red area is 28 over 9. 12 times 9 means 90. No, not 96. 108. 108 minus, this is 108. 108 minus 28 over 9 minus 28 means 0, 8. Yes. So this is equal to 80 over 9. Okay, 80 over 9. Hence, the required area is 80 over 9. Alright, that's our answer. Wow, I love this question. I loved solving this question because it involves multiple concepts regarding calculus, differential calculus, as well as integral calculus. And yeah, it's very fun. It involves geometry, it involves differential calculus, it involves integral calculus. Wow, nice question.